Okay, final example for this particular unit. So if you look back very, very quickly here, just a quick review on what we've done so far in terms of examples, going right back. So we did an example of the tree diagram. We did an example using the placeholder method or pictorial method, whichever name you want to give it. We then did an example using permutations. So this whole example, order was important, so you use permutations. This last example we worked on, the whole point here was to stress the difference between permutation and a combination. So A part order was important. So you have to calculate your N of A and N of S with permutations. In B part, order does not matter. So it changes N of A and N of S, even though earlier I indicated N of S is consistent. It's one of those funny examples where that's not true. And the final example is looking at committees. And as soon as you see a committee question, you need to immediately connect that with combinations. So data management classes decided to create a committee of 5 to honor their wonderful teacher. I'm sure the teacher is completely flattered. So through various festivities, if the class has 15 students consisting of 3 gentlemen and 12 ladies, determine the probability that, and here are your 3 cases, probability that the committee will be made up of only ladies, probability the committee will be made up of 2 gentlemen and 3 ladies, and the probability the committee will have at least 1 gentleman. So here, there is some consistency. It's all combinations. So I'm going to calculate my N of S first, the total number of outcomes. So total number of outcomes, and I'm going to use the permutation notation that I talked about in an earlier lesson, the vertical stacking. No particular reason, just so you get to see the different forms. So when you're figuring out the total number of outcomes here, you need to look at the total number of people available. So there were 3 gentlemen plus 12 ladies, and we're picking a committee of 5. So you don't have to write this out when you do the homework or on a test. I just want to show you where the number is coming from when you look back in your note. So to figure out how many 5-person committees can be chosen from 15 people, it's just the combination of 15, 5. So we find that there is 3,003 committees that exist for this particular scenario. Okay, so answering A part. Probability that you'll only have ladies on the committee. So we're looking for how many ways can you choose all ladies divided by N of S. So the denominator is going to be 3,003. How many ways can you choose ladies? When I do a committee question, this is the way I set it up. I always set it up looking at, here is my gentleman and here is my ladies combination. What it allows me to do, it's like bookkeeping. So G for gentlemen, L for ladies. There are 3 gentlemen available, and there are 12 ladies available. So if you look across the top here, the 15 and the 3 and the 12, those 2 always have to add up to how many people are available. So there are 15 people in total, so 3 plus 12. The bottom is how many you're going to pick. So if we want all ladies, I don't want any gentlemen, so it'd be 3 choose 0. And on the other side, I want all ladies, so it'd be 5 ladies. So your denominator always has to add up to, or sorry, not the denominator, the bottom or the second number in the combination always has to add up to how many people you're selecting for your committee. And now it's just calculator work. And anytime you have something choose 0, that always goes to 1, so you don't have to punch that in. But the 12 combination 5, we get 792. That's over 3,003. And again, in this case, reducing it, some calculators can handle it, some won't. You get 24 over 91. If you can't reduce or you don't want to, make sure you convert it to a decimal or percentage. Either is acceptable. So therefore, the probability of all ladies is 24.91, so about 26%. All right. So I'll just clean this up here a little bit. Group and shrink it and put it over here. Okay, on to B part. B part. The probability the committee will be made up of 2 gentlemen and 3 ladies. So very, very specific. So we're looking at the probability of 2 gentlemen plus 3 ladies. So that's the number of ways that can occur over n of s. And here's where this kind of bookkeeping method pays off. So same approach. I know I have 3 men available. I know I have 12 ladies available. So 3 and 12 always give me 15. Now I'm just satisfying the conditions here. I need 2 gentlemen to be on this committee, and I need 3 ladies. The bottom again, you're always selecting 5 people for our committee. So 2 plus 3 gives us the 5. So I know everyone's accounted for. Now I just need to go through and use my calculator to determine my answer here. So times 12 and the combination. So I get 660 on top over 3003. And again, you can reduce it or convert it directly to a decimal. Either way is acceptable. So therefore, the probability of 2 gents and 3 ladies is 20 and 91, okay, or approximately 22%. So very, very close to actually the same as picking an all-ladies committee. The final example, and I've talked to several people about this. I'm just going to go to the next page here in a sec. The probability the committee will have at least 1 gentleman, and the key phrase there, and this is what some people are going to grow not to want to see, is that at least statement, at least 1 gentleman. So that means that you should have, for C part, 1 gentleman plus 2 plus 3 plus 4 plus 5. Okay, so that means you're going to have to go through and create a question or create a solution with 5 of these, looking at all 5 cases I listed. All right. Now that's not actually true because we only have 3 gentlemen available. So if we go to the next page, technically, we can only go to 3 gentlemen. So you still have to do 3 cases. This one, however, I'm going to do an indirect, just as a practice, because there are 3 cases. Indirect's a little bit quicker, and I want to have you see a little bit more practice with the indirect method. So indirect method. We can start with what we don't want. What we don't want. And that is no gentleman. So we don't want the situation where there's no gentleman. How can we ensure there's no gentleman? Well, we can do it in terms of number of outcomes. So 0 gentlemen would equal 3 choose 0. And then all ladies, which we've already calculated on the first page. I'm doing it as a probability. I just want to look at the total number of outcomes. So no gentlemen and 12 choose 5. So we already did this calculation. This was the no ladies calculation, the first one. So we know there's 792 ways. So therefore, 792 ways no gents are on the committee. So we already know total possible. So remember, there's 2 components to an indirect method. You always do what you don't want and total with no restrictions. And this has already been done for us. It's the one nice thing with probability. No restrictions. We already know that's n of s, which is 3003. So again, if we want to find how many ways we want, so maybe I'll just add that in the statement here. Whoa, lots of color. So what we want is the total number of ways minus what we don't want. Okay, so again, we're looking at the total number of ways. So we know that there are 3,000 committees out there that exist. We know out of those 3,000, 792 have no men. That's exactly what we don't want. So if we subtract the two from each other, what we're left with is what we want, at least one male on the committee. So that means that there are 2,211 ways that will have at least one gentleman on the committee. So therefore, the probability at least one gent will equal, oops, I'm going to shrink that down a little bit, is equal to 2211 over 3003. Which again, if it reduces, you want to reduce it. So 67 over 91, or you can do it as a decimal, which is about 74%. So there's 74% chance you're going to get at least one gentleman on the committee. So therefore, 67, 91 probability, you have one gentleman. So that's an example of an indirect process. If you're doing this question on the test and you wanted to do exactly one male, exactly two males, exactly three, and add it up, you would have got the exact same answer. You would have got the 67 out of 91. Is it quicker? In this case, the argument could be made both ways, but if we're looking at more men available, then yeah, it would have been a lot more work. So remember, when you do this process here, just one last note, when you're doing this process right there, or let's see if I can make it bigger, this process is for exactly that situation happening. Okay, so in this question A, it was exactly all ladies. So that's why this method only will calculate exactly that many. Okay, similarly over here, this calculates exactly how many ways you'll get 2 men and 3 women on a committee. When you see the word at least, that means that you are dealing with multiple cases. And if the multiple cases, if there's way too many of them, you need to use the indirect method. It's just quicker and more efficient. All right. Good luck with the homework. If you have any questions, please make sure you come and ask them.